Hi, in this video I'm going to show you how to use indirect measurement to calculate the lengths or heights of various triangles. Basically with indirect measurement you've got two similar triangles, and based on the description of the problem you can create a diagram, and using said diagram you can create proportions to solve for any missing measurements that you need. Okay, so the problem we have here, we've got a flagpole that's 4 meters tall, casts a 6 meter shadow, and then at the same time of the day a nearby building casts a 24 meter shadow. And they want to know how much taller is the building than the shadow. Okay, so you've got two different things that have height. You've got a building and you've got a flagpole. So let's draw one of those. There's two ways to draw this. You can draw this either as one triangle within another, the way that I like to draw it. So there's, maybe this is my building, and then inside here, got my little tiny flagpole. That's my flagpole. The other thing you could do is you could draw two separate triangles. That's fine too. You can draw maybe like one triangle there, and then a smaller one, and this would be the building, and then this would be the flagpole. Either one works. I'm going to work with this one because I think it takes a little less space. I like it a little bit better. Alright, so let's see. We know that the flagpole is 4 meters tall. So if this is my flagpole, here's its height. I can put a 4 meters in right here. And then it casts a 6 meter shadow. Well, if this is the tip of the flagpole, and it's the same time of day, the sun's up here somewhere shining down. Alright, well, we're going to know that the shadow this flagpole casts is from the base of the flagpole to here. So from here to here is 6 meters. And the other thing we know is that the building, this is my building, casts a 24 meter shadow. So the sun's shining down from the base of the building to here, this is 24 meters. Okay, well, we need to figure out how tall the building is. And then we need to know how much, we actually need to know how much taller is the building than the flagpole itself. So we're going to have two steps, really. So let's create a ratio. We know that the size of the flagpole's shadow should be related to the size of the building's shadow, because these are similar triangles. I know the base of this triangle should be similar to the base of that triangle. Related. So 6 meters is to 24 meters. And since we picked from this triangle first, we'll take another measurement from the small triangle. 4 meters should be related to the building's height. And since I don't know the building's height, I'm going to call it h. I'll put an h here. And once we've done that, we can cross multiply. And this will be easy to solve. 24 meters times 4 meters equals 6 meters times h. So let's write that out. 24 meters times 4 meters equals, that's that, 6 meters times h. And luckily these are pretty easy to solve. I want to get the height alone. It's being multiplied by 6, so I divide by 6. 6 meters, 6 meters. Bang, bang. Let's see if we cancel some stuff out. 24 divided by 6 is 4. 4 times 4, we find out that our answer is 16 meters. We know that this building is 16 meters tall. And for a lot of problems, that's where it stops. But that wasn't the question that was asked. The question that was asked was, how much taller is the building than the shadow? I meant to say flagpole. Let's change that to flagpole. How much taller is the building than the flagpole? That's better. Building's 16 meters, flagpole's 4 meters. The building's obviously 12 meters taller than that. Right? 4 plus 12 will give me the 16. So the answer would be 12 meters taller. Alright, that's the first problem we're going to look at. We're going to look at one more. I'm going to move right over to here. There we go. See the whole thing? Move this that way a little bit. Okay. We've got our second problem. It's another similar triangle problem. We're dealing with more shadows and indirect measurement. We've got 5 foot tall Jason cast a 96-inch shadow. And they want to know how tall is his friend if at the same time of day his shadow is 1 foot shorter. So we're going to draw pretty much the same diagram, same layout. We've got, let's see, I mean, you can actually, you know what? I'll draw this a little differently. I'll draw this one the other way. Yeah. And then the shorter one. Alright, so here we've got two similar triangles as well. This angle looks a little different from this one, but let's imagine they're similar. Assume that's that, and these are from growing. Similar triangles. We've got Jason and we've got his friend. Right. So Jason cast a 96-inch shadow. The one thing you want to notice about this problem, first of all, this is in inches, this is in feet, and we really would like, and since this is also in feet, let's put them all in terms of feet. So if this is 96 inches, to turn inches into feet, you divide by 12. 96 divided by 12. 96 inches really means 8 feet. Okay? So every place you see 96 inches, we should place 8 feet. If this is Jason, 96 inches is his shadow, so we've got 8 feet down here. Alright? And then let's see. 5 foot tall Jason. Jason is 5 feet tall. This is Jason. And then his friend, here's his friend. We know that, well, we don't know how tall he is, that's what we want to know, so we're looking for his height. And we do know something about his shadow. His shadow is 1 foot shorter than Jason's. Well, Jason's shadow is 8 feet, and his friend's must be 8 minus 1, 7 feet. And now we've got the proportion that we can, or now we've got the diagram, we can set up the proportion, I should say. Pick any one of these. I'll start with what I want. I want H. I want to know the height of the friend. So the height, well, I can compare to Jason's height. H is to 5 feet, as 7 feet is to 8 feet. And now simply all we have to do here is cross multiply. 5 feet times 7 feet equals 8 feet times H feet. And now all we have to do is divide, and we will get our answer. Divide both sides by 8 feet. And 5 times 7 is 35. 35 divided by 8 will give us 4 3/8. 4.375. You can say 4.38. We're going to round to the nearest hundredth. You can say 4.375 as well, but his friend is 4.38 feet tall. Alright, that's how tall he is, and that's that. Okay, all these problems pretty much work the same way. If you have any questions, let me know. I'll get back to you as soon as I can, and I hope this was informative. I hope this was helpful, and I hope you have a great day. Alright, bye-bye.